everyone attending us in person and the several people attending us online. Welcome to the first lecture of our Colloquium series for 2023. Happy New Year to everyone, in person and online. We are very glad to host for this first speech of this year Professor Zisis Samaras from the Department of Mechanical Engineering of the Aristotle University of Thessaloniki in Greece. He's heading the Laboratory of Applied Thermodynamics there. He has been mainly working over the last decades on vehicle and engine emissions of air pollutants and greenhouse gases. He has led several big European projects. He has consulted, he has advised the European Automobile Manufacturing Association, the oil industry, and the European Commission, and also national governments. And he has also co-founded 3 spin-off companies on exhaust gas after treatment, on calculating transport emissions, and on biomass gasification. So I think he can very well talk to us about technology-driven policy research and technology-driven innovation. I cannot pretend to call him Professor Samaras, so Zizi, the floor is yours.
Thank you. Thank you very much, Theodore. Thank you very much also for the invitation and for giving me the opportunity to come here and to share with you. I was saying earlier today that your institution is well known now and is getting more and more known and respected at European level. So it is an honor for me, in addition to being together with others, to be here with you. So the title of my presentation is shown in the slide. I will stay at relatively high level because in my understanding at least, this is a very complicated issue. It is a challenge that is put by the European Commission and some European governments on our shoulders to go to net zero CO2 emissions actually by 2050. And this target is even more difficult, I would say, to be reached for the automotive sector, for the transport sector in general and the automotive sector in particular. So there are several options. There have been some decisions, at least some proposals, very clear proposals that started creating a turmoil at several levels. And this is what I would like really to go through with you, at least through my eyes or the eyes of our team in Thessaloniki. So I will say a few things about the transport, just to remind you, the transport, its general footprint. Then I will say a few words about the group and our modest contributions to the regulations and to the research in this particular area. And then I will go through the targets of reducing CO2 emissions, the well-known Fit for 55 package. Based on this, I would like briefly to talk about the different technology options that exist. Some of them seem to be the technologies of choice, and some others, they are still being discussed, but there is technology-driven research in these areas as well. I will also try to touch upon what I call here AirTrack study on carbon-neutral EU road transportation from a very technology point of view, which means what does zero emissions or net zero emissions by 2050 mean for road transportation. And I don't want to forget to spend a few minutes on the new Euro 7 regulation, because yes, the target for 2050 is net zero emissions. Yes, the target for 2035 is actually non-internal combustion engine vehicles anymore sold in Europe. But until then and beyond that, these internal combustion engines, they will continue existing, and they will continue, of course, they have to be clean. Also, with this, I would like also to bring on the table the fact that if we still want the internal combustion engine, if there is a room for the internal combustion engine, which I believe, how couldn't I actually, it has to be clean. It has to be competing to the electric vehicle. And finally, I would like to conclude with a few statements here. Now, how important transport is, I believe it's known to everyone. What maybe it is worth reminding everyone is that how big the transport sector is and what it means in terms of numbers. So we have road transportation, of course, with 250 million cars circulating at the EU roads, EU 27 roads, and 36 million trucks, circulating on almost 4.5 million kilometers of roads. So we can understand that, and you can see, you know that Europe is really full of roads everywhere, urban and highways. But in addition to the roads, there is always the maritime traffic that we tend to forget, but it is extremely important since the maritime traffic, the maritime transportation is responsible for 80% of the transported goods in Europe and worldwide. And in Europe, we have something like 12.5 million, thousands of vessels of a certain capacity, which is a big capacity that constitute a very important fleet circulating around our seas. And evidently, the air transport is equally important with something like 2,500 passenger vehicles in Europe and transporting over 650 million passengers per year. So we're talking about very big numbers, and these big numbers are definitely reflected into the footprint of these activities. So if we focus on CO2, which means to a very large extent it means energy, because until now we are only burning fuels, therefore CO2 is a very clear indicator of how much energy we need for this kind of operations. We can see that transport is the single most important producer of CO2 in Europe, with more than 25% CO2 produced, followed by the industry and by the energy production. So, and as I will say in a few moments, the problem with transport is that it grows. All the other sectors go down, while transport continues growing. And of course it continues growing because we are very mobile. We are moving, and we are moving a lot. If we focus on the different transport modes, you will see that the passenger car mode, this road transportation mostly, is responsible for over 70% of CO2. So if we want really to tackle CO2 emissions from road transportation, we have with priority to tackle passenger cars. And of course, road transportation as a whole. We shouldn't forget navigation nor civil aviation, as described before. However, priority was and still is on road transportation. And if we look at the evolution of greenhouse gas emissions from transport over EU27, from 1990, which is the base year of all the calculations, until almost 3 years back, 2019, where our detailed statistics stop, you will see that we have some sectors or modes that are decreasing, and this is railways in this case. Some others are increasing very fast, like aviation, as you would expect, and road transportation, which is the most important here, is fluctuating, going up and down, but it is at relatively high levels. And if we go to the detail of the road transportation, again, light-duty trucks and cars are the ones that are leading the increases. What is not shown here is actually the absolute numbers. And of course, light-duty trucks do increase, however, their number is small. Why do they increase? Because delivery has increased a lot over the last years and is expected to increase even further. We have set, as Thodoros kindly said in the beginning, we have a group in Thessaloniki that has been involved over the last 20 years in these activities, in the activities of supporting the European Union as a whole, in particular DG GROW, but also DigiEnvironment in setting regulations, in conjunction also with the industry, both the automotive and the oil industry. So we largely support our activities with a modest but up-to-date testing facility that includes chassis dyno, 2 chassis dynos for cars and motorcycles, engine benches to make detailed measurements and analysis of energy flows and emissions from engines, looking at particular topics like cold startability. And recently, we have been launching ourselves into electrification, looking at battery electrothermal testing, going much more into the detail of the electrified vehicles, while we are always very much interested in looking at the real performance of the vehicles on the road, not only focusing on in the laboratory, but also seeing what happens under real-world conditions on the road. Our strategy, as it developed, was really to look at the small scale, to look at the fundamentals first, looking, for example, at the reactions that take place in the catalyst, combustion-related characteristics that we could identify, separate, and study, then upgrade to a higher level. It could be a catalyst, or it could be a reaction, overall reaction in a reactor, and then move it to a vehicle or the final application. That was our target from the beginning, and to a certain extent we have accomplished a few things here. And we have been looking at renewable fuels from the beginning, of course, always in conjunction with the internal combustion engine, because the internal combustion engine is a very good carrier or a very good device that is in the position to use energetically things that are not easily usable under other conditions. For example, gasification of biomass, which means turning a solid fuel into a gaseous fuel in order to be energetically usable. Sorry. Up here. In order to, as we have been evolving, we have decided to set up as a group a spin-off company. Actually, we started with 2 spin-off companies. One was recently purchased by a bigger American company, and we are focusing now only at Emission, that is trying really to commercialize some of the tools and some of the services that are being developed at university level. And these services include engineering services, such as full-scale simulation of internal combustion engines and vehicles, with particular emphasis on exhaust effect treatment devices, catalysts, diesel particulate filters, and the like. And with recently a lot of emphasis on electrification. We find many commonalities between the catalyst and the battery. They are both reactors. They are both systems that they can be thermodynamically very well described, including chemistry. And we think that the methods that we have developed for catalyst simulation or for catalyst modeling are also applicable, generally speaking, for electrification as well. We have also another area that looks at the interface between emissions and air quality. So what we can produce as input by understanding of the vehicles and the vehicle operation. And this can be transferred in a usable manner to those scientists and colleagues that run air quality modeling, but also expanding to other areas like cost-benefit analysis and life cycle analysis, since they are more and more needed in order to better understand the new powertrains and the new powertrain options that are ahead of us. And we have a particular emphasis on CO2, developing specific tools that may also be used for optimizing the operation, in particular of trucks. Only a picture of some of the recent studies that came out from our group, and the two first do support the proposal on Euro 7 vehicle. Of course, we were a relatively big consortium from different European institutions, and we looked at both the technical measures, also on the impact assessment, and of course, other much more detailed studies looking at the CO2 and fuel consumption, emissions of passenger cars, and their modeling implications. Having said that, I think it is necessary really to go to a very brief discussion of the so-called Fit for 55, the EU's target of reducing net greenhouse emissions by at least 55% by 2030. This is a very ambitious target, as you understand, and it includes a large number of activities that have to be undertaken, and it seems they are on track. I would like to focus on three areas here. One is the CO2 emission standards for cars and vans, which is something that happens only at European level, and it is Europe that leads the way in this area. The other, but adjacent to this, is the alternative fuels and the infrastructure which is necessary for these fuels. And finally, I would like to say one or two words about aviation, maritime, and not to forget the trading system. However, it is, I think, very interesting to take a look at this table here. This table, based on JRC data that we have contributed to, shows, in comparison to this target, this 55% has to be compared to 1990 emissions. So we have to reduce by 2030 our emissions by 55% as compared to 1990. And this is a first assessment in 2021 for the different sectors. And you can see, this is the world picture. This is an estimate of JRC for the world. There is a constant increase everywhere in the world of all CO2 emissions. There has been, in particular because of China, but also India. This means economies that boomed, flourished during this period. And if we look at Europe, that is expected to lead the way here, is leading the way, there is a general trend downwards. All sectors are reducing, have been reducing, with one exception. You can see it's road transportation. Transportation has increased by 16%, and overall, we need an additional 30% approximately to be reduced in 7 years. Actually, we had, if we look here, if we look at the minus 27, I should make this mistake again. All sectors are minus 27 at European level. So, in principle, one can say that if these sectors here do reduce much more than what is requested, then there is a certain margin, in principle, for transportation to not reduce so much, or maybe increase a little bit. However, we have done something like minus 27% over 31 years, from 1990 to 2021. Now, it is asked to add another 28% in roughly 9 years. Is this possible? This is a challenge, this is a bet. But this, at the same time, requires technologies, and not only technologies, also change of attitude and other approaches, digitalization, under the general term digitalization, to be deployed in order to see if we are in the position to reach those targets. If we look at road transport and CO2 emission standards for cars and vans, you see what the targets are. Currently, we are at 95 grams per kilometer. This is only an indicator, it's not reality. In reality, cars do emit much more than that, something like 40 to 50% more. But this is an indicator, and the issue is not if it is 95 or 120. The question is if you reduce 95 to 50, that 120 will also equally reduce. This was not happening over the last 10 years. Actually, cars were kept constant while reducing their emissions over the regulated cycles. But if we believe, and we do believe now, that we will have this reduction, then it is expected that by 2029 we'll have a minus 15% reduction, and then by 2030 until 2034, minus 55. This is thermodynamically impossible to be done by the internal combustion engine. This is stopped by the second and the first law of thermodynamics. Actually, the second. Yeah, this is not possible, simply. So how can we do that? By changing, not the law cannot change, but by changing the powertrain. And this is the big bet, and this is the big question. And of course, it's not only about cars, it's also about light-duty trucks or vans, and we do expect, with a lot of curiosity, what the targets will be proposed for heavy-duty vehicles. These are not announced as yet. Now, the preferred choice, and I will speak a little bit in a few minutes, is the electrification. It's not electrification, the general term. That includes also hybrids and plug-in hybrids and all these combinations. No, it's BEV. It's battery electric vehicles only. That's the preferred choice at European level. And for this, and there is also a second possibility, and that's called hydrogen. Hydrogen to be used in fuel cell vehicles. This is not stated in the previous slide. It is inferred. And by inferring that there are two basic technologies that can be deployed for this kind of targets, then we need infrastructure. Otherwise, there is a big risk that the consumer will never buy those vehicles. Or even if the consumer buys some of those vehicles, the consumer does not use the vehicles. And what is the anxiety here is called range anxiety for the electric vehicles, and similarly for fuel cell electric vehicles. It is that you are running out of battery, you're not running out of power in the battery, and you cannot charge. Or you have to charge for maybe 3, 4, 5 hours, waiting for 3 hours in order to continue your trip. This, everybody knows, unless you have a law and order kind of approach, you do it, which is impossible, I would say. This is not sustainable at our societies. Therefore, it is necessary to go on with infrastructure. Fit for 55 asks for one charging station of a certain power every 60 kilometers on the main roads, on the highways, every 60 kilometers. And it also asks, and this is really very challenging, one hydrogen fuel stations every 200 kilometers. We are far away from those numbers today. But it is not impossible, really, in particular as regards the charges, to be achieved. And there are a few other things that need to be taken into account. You have to have compatibility. You cannot go from one place to another, and you cannot charge just because you are incompatible. You have to have a global way of paying those things. So you have to have these types of infrastructures that may seem simplistic or very straightforward, but if they do not exist, then we are risking of a failure here. A very similar approach is for the ports. It is assumed that ports have to be fully electrified, which means that all operation in the ports, have to be done electric. Therefore, they are asking that at least 90% of the container ships and passenger ships have to have access to shoreside electricity supply, and so on and so forth. And a very similar approach is for airports. Therefore, what is inferred here is that we have to offer the possibility that aircraft operations on the ground and in the ports, operations of vessels, have to be all fully electrified. But it is known that it is impossible to imagine in the future of 2030-40 to imagine vessels being 100% electrified and aircraft to be 100% electrified. Therefore, the solution, it is accepted that for those vehicles are renewable fuels. So we have to continue in the direction of renewable fuels. That's why what is being asked by the regulation is that by 2050 and already by 2030, there is a certain amount of renewable fuel, of zero carbon fuel, zero carbon emission fuel, to be available at European level, in each country, in each airport, on average. And something very similar, but expressed a little bit differently for ships. For ships, what is expected is to reduce the greenhouse gas intensity of the energy used on board with these targets, 75% reduction by 2050. This means that it is given an incentive to, but also a must, in order to reduce and change, to reduce CO2 emission and change towards new directions. Finally, which is not something that should be forgotten, there is the EU emissions trading system for CO2. So there is a kind of banking that has prices and can actually penalize those that do emit higher CO2 emissions. Until now, transport was exempted. Now, I think the big step is that transportation will be part of the whole system. Now, if we go to the technologies, so we said what the targets are. Maybe I should have started with the technologies, but in the end, the technologies have, to a very large extent, been decided. And I have to start with the two technologies of choice that are expected to replace the internal combustion engine. This is a very simple but standard architecture of that reflects the energy flow and the related efficiencies in a conventional vehicle. What is the major drawback here? What is the major problem in terms of efficiency? The internal combustion engine itself. It is versatile. It uses a fuel that is perfect. It is optimized to a very large extent, but it cannot exceed 40, maybe 45% of efficiency. So one half is always lost as heat to the environment. And this is the point here that actually produces more CO2 emissions than one would like to, or could possibly tolerate. Overall, if we look at the different efficiencies, we have an efficiency from well to tank. We have an efficiency in the powertrain, in the engine. Then we have another efficiency in the transmission and the overall transmission of the movement and the axle. And then we come overall with something which is around less than 20% overall. So we burn 100 and we get 20. Sometimes we get only 10 stop and go traffic in the different cities. Now, if we move to an electrified vehicle, what is the difference? So basically, we're talking about the same, of course, chassis, the same vehicle, it's exactly the same. So what we have is an electric motor, which has its stored power in a battery, and the battery gives its power and its current to an inverter, because, as you probably know, batteries do have direct current, and what we need is alternative current in order to move efficiently our motors. So you have an inverter, and the inverter drives the motor. Overall, the efficiencies on board of these vehicles are extremely high, are above 80%, and they can be even better. Where is the drawbacks? The drawback is a little bit on the charger. In the charger, we have an efficiency of 85%, but we have this topic here. We have a 40% efficiency from the production, as an average of the production of the energy, of the electric energy to be used. Where does it come from? From the average efficiency of the power production in the different power plants across Europe, across the world. As long as they are power plants operated on coal or on similar type of thermodynamic approaches. The thing is that with this 40%, still, the overall, even with this 40%, the overall production, the overall efficiency is 27%. So generally, it is better than this efficiency. So by simply moving to an electric vehicle, one can gain already something like 10%, which is or should be reflected into CO2 emissions. And the other approach, of course, this is the fuel cell battery electric vehicle. Again, this looks like the electrified vehicle. It is an electric vehicle. It only includes a fuel cell that produces, with something like 60% efficiency, electricity. We do have lots of electric vehicles, perfect electric vehicles, very light, very versatile, very well done. The problem with all those vehicles is battery, was and still is battery. It is the range. While here, this fuel cell is an excellent machine or an excellent device. The problem with the fuel cell is that we have to have hydrogen, pure hydrogen. Otherwise, very difficult to continue. And unfortunately, the prospects as they are today, they don't look very well. They don't look very good. This is, again, a JRC study we contributed to that says what will be by 2030 the density of the charging stations across Europe. And what we can see is very big differences between different countries of Europe. You can see a very dense Germany and England, even Portugal, and a very low density in countries like Romania and Greece. And this has to be somehow rectified in order to be in the position to promote the electrified vehicles. But I have to say a few things about the biofuels. Biofuels, they are not a unique family, and biofuels, they are generally considered as fourth generation, from 1 to 4. This first one is well known. It is actually biodiesel, bioethanol, and this is being used in all European countries already. The problem with this is that it is negative in net energy gains, and there is this contentious issue of fuel versus food, because it is used, or these biofuels are coming from food-based grains. The second generation, which is almost developed, it is a non-food crops, wood organic waste, food crop waste, and specifically biomass crops. This exists already. It is well advanced. It is a TRL almost 8 to 9. The problem is always that it is very expensive. The overall effort is being put on the third generation, which is an algae-produced biofuel, that it uses similar technologies and techniques as the previous ones. The thing is that still technologies to grow algae are not very well advanced. There is a lot of emphasis and effort being put here, and there are technology problems that have to be overcome. But there is a very big research activity in this area. And finally, the final target is the fourth generation biofuels, which, on the other hand, are very far away in the future. And probably they will never, or they will not arrive anytime soon. What is very important here to mention is the e-fuel. E-fuel stands for electrofuel, and they are hydrocarbon-based fuel that can be produced on the basis of electricity. And they are considered as interesting and neutral and carbon neutral only when renewable energy is being used for their production. Their simple steps in a very simplified way is as follows. Electricity is used to electrolyze water. And water, of course, is split into hydrogen and oxygen. And then what is missing from this picture, when hydrogen is combined with CO2 and CO, can either go the way of methanation and produce methane, the so-called e-methane, or can go via the way of synthesis, Fischer-Tropsch synthesis, to produce hydrocarbons, similar to gasoline and to diesel. The e-fuels, and these fuels can be used in combustion engines. The interesting thing is that we also have the direct usage of electricity, and also direct usage of hydrogen. And all these need to be stored. And storing electricity is difficult. Hydrogen is not impossible, but also difficult. And finally, of course, all these liquid fuels can, or even gaseous fuels, can be relatively easily used. Now, there is a lot of effort being done currently, and there are different chains and different approaches that also depend very much on where you produce those fuels or where you produce electricity. To the left, these sketches here assume that electricity is produced in Europe. And there are differences between the north, the central part of Europe, and the south part of Europe. And we can see different pathways going to e-methanol, for example, or even to e-ammonia. Ammonia is considered to be a very important fuel for maritime applications in particular. I don't think we can even consider ammonia for road transportation. But here, everything is limited. In Europe, everything is limited. That's why there are all these efforts to go to other types, other parts of the world. And here, these are calculations for MENA, for Middle East, actually. And Cyprus is very close to it. There are possibilities to produce the electricity and the fuel, and then transport the fuel from MENA countries to Europe, or do the other thing, take the electricity, move it to Europe. This was, to a very large extent, abandoned. Usually what is being considered is really to transform this to a liquid or gaseous fuel, liquefy it, and then transform it and transport it to Europe. I would like to say a few things about what does it mean, what all these possibilities mean in terms of numbers, in terms of effect on the overall system in Europe, as we saw it in AirTrack. AirTrack stands for European Road Transport Research Advisory Council. It is a combination of industrialists and academics and member states that do support research at European level, and also provides input for the research activities at European level. So we looked at different powertrain scenarios, different optimistic and pessimistic ranges, combined with them electricity scenarios, always looking at renewable and a little bit of non-renewable, and different fuel scenarios. The fuel scenarios are of particular interest. Here you can see the combinations that we looked at, advanced biofuels in one line, e-fuels, solid e-fuels, mixed and limited fossil. It is there is an infinity of combinations and infinity of possible solutions to a very complicated problem. And what needs to be really kept in mind is this, to me at least, these three particular graphs that attempt to calculate how much energy is necessary in order to produce 1 megajoule of useful energy to the tank of the vehicle. So the reason why electricity is so appealing is that in order to produce 1 megajoule of finally to the battery energy, you need only 1.1 basically megajoule to be input. So you are very close to 1-to-1. So you can use whatever you produce, you can use it directly in the vehicle. If you go to biofuels, unfortunately, you need 60% more energy in order to produce 1 megajoule of tank energy, out of which only, unfortunately, only 0.4 are usable. And this is the major problem of e-fuels. For 1 megajoule of e-fuel that will give you only 0.4 megajoules of usable energy, you need 2.5 megajoules of input energy. And of course this can be done, but on the other hand, it is necessary to think how one can arrive to those things. So we went through a number of calculations. I don't want to go through all of these. And we saw that looking only at the ranges of different types of energy that may be required by 2050, it is clear that a new view to the overall system of energy production in Europe needs to be revisited, needs to be visited and decided. And if we're talking about electrification in particular, we have to keep in mind that we will need an add-on 40% of electricity generation in order to be in the position to power our fleets. In between, as I said, Euro 7 is providing a number of additional opportunities that attempt to make our conventional vehicles as clean as possible. And this includes fuel and technology neutral emission limits, so there is no difference between diesel and gasoline. There are new pollutants like ammonia, N2O, and others. And also, in-vehicle battery durability is considered to be an important aspect of Euro 7. Equally important, nothing is tested on the laboratory anymore. Everything is brought on the road, and all conditions that can be found in the road, either very, very hot conditions, as here in Cyprus, for example, expanding the outside temperature at 45 degrees from 30, maximum 30 degrees that existed until now, or to very low temperatures that can be met in Norway, but also no trip is excluded. Every type of driving is part of it, will make things, hopefully at least, cleaner than before. The final topic which is important here is that digitalization of the vehicles is on the way. And what has been decided is that there will be a centralized follow-up of the operation of the vehicle via the so-called onboard monitoring systems. Onboard monitoring system, which means that incorporating, using existing sensors, adding new sensors on the vehicles. And these sensors, we will start with NOx emissions, ammonia, and PM, and particle matter. All this information has to be analyzed on board, transmitted to a central computer, and then analyzed at higher level. Maybe this information can also be combined in big databases with type approval data, with PTI, periodic technical inspection data, as well as remote sensing data that are being collected across Europe, which means a system, centralized system, is being deployed currently that gives the opportunity to have a full follow-up of the operation of those systems. And this is just an evolution of existing technologies that were already developed in different vehicles. I think I exceeded a little bit my time, but the message, at least for my side, without necessarily going through all these details of the conclusion, is that Europe is betting on technologies that were not available in Europe and are being currently much more developed, or there is a big effort to be developed, be maintained and used. When I was studying mechanical engineering several decades ago, actually, it was clear to me that battery was the drawback and was the bottleneck in the development of the electric vehicle already in the late 1800s, when the first vehicles started appearing, which were electric, of course. Now it seems that the usage of the vehicle, the possibility of monitoring the operation of the vehicles, monitoring the operation of the batteries, the interconnection of the data, providing guidance, specific and customized guidance to the drivers, may give new opportunities for alternative technologies. Although there are many topics that still need to be looked at, and which is a very good thing, of course, for researchers like us, still I believe that the mass deployment of these new technology vehicles, if successful, which I honestly believe it has to be successful, and it will be successful, it will give additional opportunities for Europe in order to lead some of these developments at global scale. The final point that I think comes out from all these discussions is that we can no longer continue looking at closed systems. For example, putting simple emission limits for a vehicle at the tailpipe is not sufficient, because you can this way promote technologies that otherwise may introduce important negative effects. That's why life cycle analysis should be further developed, should be standardized to a very large extent, and that's the reason why there is need for information coming from all sides in order to make us a bit more intelligent, in order to take more wise decisions in the end. So with this, I would like to thank you very much for your attention, and I'm open to questions or remarks, comments. Thank you.
Professor Samaras, I am Christos Panagiotou. I'm from research at KIOS Center of Excellence at University, and also at the Department of Electrical and Computer Engineering, also at the University of Cyprus. Thank you for your interesting talk. I will start where you ended, analyzing the entire life cycle of the, because we're analyzing and want to drop the CO2 emissions by 55% and so on. And electrification seems to be the way to go. But for the electrification to be successful, we need batteries, and batteries also pollute. What are we going to do with all the batteries we are going to end up having to dump after several years?
Well, this is a critical question, and as you probably know, there is enough research activity going on in this area. There are several Horizon projects that are specifically designed and focusing on recycling, on new materials, on alternative materials, on better usage, on second-hand batteries, on second life of the batteries, and so on and so forth, not only at European level, but also there are, and that's the very interesting thing, it seems that there is, in the automotive countries of Europe, there is a much more intense activity in this area. So Germany, for example, in the United Kingdom, they have invested billions, or literally billions of euros in the battery topic. And definitely recyclability, usability, second life, as I already said, are the main topics. The answer in this kind of question is that should we first resolve all our problems before we launch ourselves into reality? I think the answer is no. And probably real world will give us also additional opportunities if we are clever enough and if we are focused enough to find solutions.
But you see, we have the nuclear, and then we started producing nuclear, and then now we don't know what to do with the
nuclear waste.
Yeah,
Yes.
so
I don't think it's similar. I hope it's not similar, at least. But yes, you're absolutely right. I mean, and it seems that I don't think we can be so intelligent to avoid mistakes or to avoid. I think this is against the second law of thermodynamics, just to be. I mean, it is impossible not to produce entropy in the end. You have to produce entropy. And the question is how less and how efficient you can be in order to prolong some of the operation. It's very theoretical what I say. It doesn't answer your question, but I'm sure you understand what I'm trying to say. And yeah, sorry.
Thank you for this very informative provoking in certain ways presentation. One thing that it's well known that the hardest sector to decarbonize is transport. But one discussion that I cannot get enough information is actually shown in one of your slides. There are modes and modes of transport. And the striking fact that was shown in your slides, rail, for example, which can be easily electrified, does not need batteries.
Actually, it is electrified largely already.
Largely, yes, largely it is. It can be easily, totally electrified. Doesn't need batteries, so you skip that headache. But I'm not aware of intense activity, which is obvious that is needed to switch modes of transportation. Abolish trucks to the degree possible and switch to rail. And there actually a history of petty interests, is well documented in the US, killing rail in order to promote trucks. And that will not emerge from technology, will not emerge by making more efficient engines. And the second law of thermodynamics is going to be valid and helpful in this direction, but it will be a decision that has to be enforced top-down. Could you comment on that?
Yeah, thank you. I think you touched upon a number of topics in parallel. Let me comment on some of them. First of all, I don't think that a rail can be fully electrified. There are areas that it is basically impossible and shouldn't be electrified, but that's one small. The second thing is, yes, there is a very big effort currently, with a lot of friction at European level, to electrify trucks the way the trains are electrified. There are two systems here, maybe you haven't heard, so this gives me the opportunity. One is the so-called Siemens system with catenaries. So instead of having catenaries on rails or above rails, you have catenaries above the road. And there are several hundreds of kilometers, test kilometers in several countries that do that. So the decision about the trucks is not finalized as yet. There is a very high possibility that trucks will be battery operated, but with small batteries. So they will have the possibility to get the electricity from the catenaries. And then, because you cannot have catenaries everywhere in Europe, when they will leave the highway or the electrified road, then they will operate on battery for a short period of time. This is the philosophy. What I should also mention is the second technology, which is equally interesting, because the catenaries, we know, it's an induction. It's on the road. So you send the electricity via induction to the truck. So the truck runs on a rail that sends electricity with induction. Both approaches are very valid, and there are strong believers in this, strong believers. What I said was a kind of comment to rail, and then maybe what we have in our heads as rail, maybe it's a different thing in 10, 15 years from now. So what is this that I just described? And it exists. I mean, there is no big truck manufacturer without pilot in this area. Volvo, Daimler, Renault, everybody has that. So this is not decided as yet. But I agree to the other thing. You said the following. I would call it intermodal shift. So take people from passenger car with occupancy rates of 1.3 and put them in a train with occupancy rates of 80%, 90%. This is something that is being tried over many, many years, with decisions, with incentives, with, in some cases, law and order type of approaches. How can it come from above? I mean, what can we say? That If I see you with only one person in the car, I shoot you. Or something like that. I mean, it should be so strong, which... Something, yeah. You have to do something here. This is a discussion that goes on. I mean, we have made calculations even maybe 30 years ago that illustrated that intermodal shift is a very good possibility. But are we lazy? Are we, as societies, I mean, we have been fed with lots of very cheap oil over so many decades that it's very difficult to change our mentalities. I don't know. I'm a very simple engineer here, and I think this goes much beyond. But I totally agree with you that all these routes, all these pathways have to be followed.
Fabio Montagnino. As we are talking about emerging possible technologies, you have been mentioning e-fuels. What about solar fuels? So where you are generating the fuels by catalytic reactions at high temperature, which got an hype years ago. There are some niche, let's say some niches and projects going on, but you have been not mentioning, so are they over or is there any possibility?
Thank you. As a matter of fact, there are tons of things that I haven't mentioned. I think I tried to mention only the mainstream activities. These solar fuels, they have been called synfuels as well, with Y, yeah, these kinds of things, yeah. There is always a research activity here, which is not very strong. The reason is, it seems there is a very close relationship nowadays between where the research money is invested and where policy goes. So after the European Commission and the member states, I have to say that, major member states decided that we go these directions, there is no room for synfuel if we want in 5 years, in 10 years, to have enough quantities of fuel that can fuel our 250 million cars. Maybe not all of them, but a big part of it. We're talking about millions of tons. And this is not possible with these synfuels, not even possible with biofuels. The very crude, I agree with you, approach of the e-fuel, which means electrolysis, and then you go methanation, you go Fischer-Tropsch, you need, yeah, I agree with you. But this is the only thing we can think of right now.
8 years ago, Chiyoda, so the Japanese, they were selling, I got the leaflet, they were selling plants. They were saying we are going to build plants in North Africa and sell. So they were claiming they were in the industrial stage. So it's always like this, things are disappearing and appearing.
I fully agree with you.
Process.
I totally agree with you, and maybe in the future this will reappear. I mean, it shouldn't be killed. This is my understanding. We have to keep that, although it's not going to be mainstream in the next 10 years. For sure not. Maybe more. Not even biofuels. Honestly, I don't believe in biofuels. With all this fuss that was created around the biofuels, I think they are only algae, if and under specific conditions, still.
2 years ago, I was listening to a talk of an expert. This is a little bit of an implication of what you're saying, this policy shift towards carbon-free transport. I was listening to a talk from experts on fossil fuel usage over the next 20, 30 years. And it was I think it was the director of the European Development Bank who said natural gas usage is over, investment is over. So what would be the implication on fossil fuel usage if this policy was to be implemented? Countries are going to war over this. And there'll be a massive change in policies.
Yeah.
I mean, 2050 is just down the road. What's your call on that?
I have the same question as you, actually. The only answer I have here is that First of all the big 8, I think, the big oil fuel companies, they don't call themselves fuel companies anymore. They call themselves energy companies. And they are launching themselves, they say, in different activities, which is true. It is true. On the other hand, we have a war right next door, right? It's not. And then everybody is suffering from methane. I have the slightest idea what is going to happen. Natural gas, the only thing I can say here, natural gas was not critical for the transport sector, never. So this is what it affects the transport sector only via its impact on oil prices. So that's the only real connection. Otherwise, it was always considered to be a very good fuel, a very clean fuel. I'm changing a little bit the subject. Very clean fuel, but was never used actually. Let me remind you, Volkswagen. Volkswagen, not 10 years ago, maybe less, invested a lot in offering not only gasoline and diesel vehicles, but also natural gas vehicles, this the GI or whatever. A complete failure. So I brought things a little bit to the low level, but it's extremely difficult to give any answer, from my perspective at least, to your very political or philosophical question, if you wish.
I think we have the last question. I mean, my question will be completely heretic, right? But since it will be the last question, it can be hopefully entertaining. Somebody would claim that it would be easier for humanity, instead of solving these hard problems, to eliminate the need for traveling by focusing on technologies like virtual reality, augmented reality, where you can work from home, you can see your friends from home, you can go on vacation from home by wearing...
What?
Wait.
Can you imagine that?
You know, you are wearing a special uniform and you can travel to the Caribbean. So, I don't know, it sounds like a ridiculous question, but...
No, I don't think it is. I don't think it is heretic. Actually, there are 3 ways of reducing emissions, right? One is, of course, technology and continued use. The other is reduced travel, of course. And the third is use more efficient modes of transportation. And maybe this can be also partly an efficient mode of transportation, virtual. I don't believe there is a silver bullet. That's why I'm also skeptical about electrification as well. We have been living with one machine for the last 100 years to move, and we have to say that our civilization, civilization currently is due to 2 machines, in my understanding. One is the diesel, and the other is the aircraft. Because with the diesel, it's not about us moving, it is about earth movers, it is about excavators, it is about ships, it is about trains, big trains in the beginning. All these were diesel, and it was, I have to say that it was an excellent machine. Still is, actually. The problem is not the machine, the problem is the fuel. So, going back to what you say, I think the solution is a combination of all those things. That's why I also slightly a bit mentioned in the end of this connectivity that timidly starts. Already now, every car communicates with the manufacturer. We know it or not. There is this over-the-air communication, which is a standardized thing. Now, regulators enter into the game and use this communication. And all those things have to be somehow put in one basket, in one big basket, and see where we can optimize and how we can optimize. We will never do that, as you know. But at least let's try. Let's try to go and take these approaches as well. Maybe not go every year to Caribbean, maybe every 3rd year, and the other 2 years we stay home and we do it virtually. I hate that, but...
Okay, I think we are on time, and we would like to thank you very much. I've already received an email message. I think it's from an officer at the Transport Ministry who was attending it and wants to have the presentation, of course. But I think also the recording will be available on our YouTube channel, Tony Live. So We would like to thank you very much.
You're
and
very
we
welcome.
might continue the discussion outside.
Thank you.